Atmospheric pressure is the pressure from the air particles in the atmosphere. Remember that a pressure is a force spread out over an area. And air pressure is caused by gas particles colliding with us. So the can, in this example, experiences a pressure due to collisions from the air particles. We can compare other pressures to this atmospheric pressure at the Earth's surface, which is 1 atmosphere, or around 100 kilopascals. We don't feel this pressure as our bodies are adapted to it, assuming we don't go to high or low pressure environments. But how do we know that this atmospheric pressure exists if we can't feel it? Well, atmospheric pressure can be demonstrated by removing all contents of a container, including the air particles. There is actually an outward pressure from the inside of the can as air particles within the can collide with the inside edge. The pressure doesn't affect the can as the pressure from the air inside provides forces that balance the forces from the pressure of the air outside. We can remove the air inside using a vacuum pump, so no particles at all remain in the can. There is now only an inward pressure, so there are only collisions from outside the can, and the pressure is unbalanced. Therefore, after the air has been removed, the can crumples, as the resultant forces push the can inwards, causing the shape to change. You don't need to remember the details of this experiment for GCSE, but understanding it helps us understand what atmospheric pressure is and its effects. So is the strength of atmospheric pressure the same everywhere? Well, atmospheric pressure is actually reduced far from the Earth's surface, where there are fewer air molecules. The atmosphere is gas that's held close to the Earth by gravity, and the number of air molecules becomes less with distance from the Earth. So the atmospheric pressure varies with height. Closer to the Earth, there are more air particles, so more collisions. And as there are fewer molecules higher up, there are fewer collisions to cause pressure. Atmospheric pressure can also change with weather, as air currents move molecules. So it might be less or more at certain points on the surface due to humidity. But what sort of pressure changes do we see as we move away from the Earth? Well, we notice great differences in atmospheric pressure when flying or climbing mountains. For example, consider flying on a plane and also the peak of Mount Everest. These are both between 8,000 metres and 10,000 metres above sea level. The pressures experienced at the peak of Everest and on a plane at height are much lower than at sea level. They're about 0.3 atmospheres. Steps therefore must be taken at this low pressure, such as pressurized cabins in a plane and oxygen supplies for climbers on the mountain. For your exams, you need to be able to compare the pressure at different points of altitude and explain why this difference arises.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!